let's see what the answers are. We have said that floor division always rounds downwards towards negative infinity. So if minus 5 true division 3 is minus 1.6, when we round downwards towards minus infinity, we will get minus 2. Now, if minus 5 floor division 3 is minus 2, let's try and understand what minus 5 remainder 3 will be. So here x is minus 5 and y is 3. So the answer is x, which is minus 5, minus this result. Well, this result we've just calculated is minus 2. So expanding this out, x is minus 5. This result is minus 2 times 3, because remember y is 3. So it is minus 2 times 3, which is minus 6. So the answer is going to be minus 5 minus negative 6. And of course, minus and minus is plus, so this will give us the answer 1. I'm mentioning this to you not because I want you to be able to work out these types of calculations in your head. We shouldn't be working out these types of calculations in our head. That's what computers are good at. I'm mentioning this example to you because if you ever find yourself writing code like this, expressions like this in your code, please remember that it is very, very difficult for someone to work out what you mean. It might be difficult for them to reconstruct what you're trying to do. And it's not just other people who will struggle to reconstruct what you are doing. You yourself will find it difficult to reconstruct what you were doing several weeks later if you happen to come back to this code. So my general advice to you is when you write expressions of any type, please make sure that you find them easy to read. If not, please try and find other ways of writing these expressions. Now coming to 0 to the power 0. It might seem reasonable to you that this is going to result in some sort of an error, because if you consult most mathematics resources, they will tell you that this is not well defined, 0 to the power 0. And it could have been that the developers of Python chose to treat this as an error. In fact, they have chosen to define 0 to the power 0 as 1. And it's important for us as users of the language to be aware that they have made this choice. You and I might disagree with this choice, but as users of the language, we are bound to respect the choice that the designers have made. Now, certain other types of operations do indeed cause errors. As you can imagine, if we try and divide by 0, whether we do this with the remainder operation, or with the true division operation, or with the floor division operation, this will result in a special type of error called a zero division error. When you actually try this out in the REPL, you will get a longer error message. I have just shortened it here for simplicity on the slide.